Welcome back to Mr. Gard's maths class. In this lesson, we're going to be looking at quadrilaterals. So, as I've written here, it's any four-sided shape. If you think about the word, quad means four, and laterals means sides. So, four sides. It's really important to notice that our internal angles always add up to 360 degrees. Okay, that's going to be really important. So the internal angles of a square we'll look at in a second, but they're going to add up to 360 degrees, unlike a triangle, which was 180 degrees. We'll see a pattern in a later lesson. There are two types of quadrilaterals in the sense that you can have convex quadrilaterals, which is this one here, or non-convex. Now, the key feature here is a non-convex quadrilateral has an internal angle that is greater than 180 degrees. Generally, if they have one of them, you're going to have three pretty small angles as well. Whereas over here, all angles are less than 180 degrees in a convex or a regular looking quadrilateral. Now, we're going to have a look at a few other regular quadrilaterals. Apologies if you could hear my dog barking just before. Listed here are the main ones. Some of them, this will be quite common sense. A rectangle. I'm going to put a few little symbols as we go here. This side and this side matching. This side and this side are matching. Okay, we know that a rectangle interior angles are all 90 degrees. Like so. Remember, we sort of write that down as a little square. That's an indication that it is 90 degrees. You'll also note that we could even say that this is parallel to this and this one is parallel to this one. There's a lot going on there in just a plain old rectangle. Square, same deal. Except in a square, we know that all four sides are the same. Interior angles are all 90 degrees, so I draw my little square shape. If they're all 90 degrees, 90, 180, 270, 360 degrees, all four angles add up to 360. A rhombus is actually a four-sided shape where all sides are the same length. Now, I've tried to draw this with all sides being the same. It's effectively like having a square pushed over. This angle matches this angle, and then this angle matches this angle. Again, we have some parallel lines. These ones are parallel to these ones, and so on. Parallelogram is effectively a rectangle pushed over. So this side and this side are matching, this side and this side are matching. Just like the rhombus, you have these angles that match up like so. I've got some more parallel lines. Like so. So they're all pretty similar. So the rhombus and the parallelogram are effectively the square and the rectangle, just pushed over a little bit. Next shape is a kite. Now a kite has these sides matching and these sides matching. Okay, they have to be different, otherwise it just becomes a rhombus or a parallelogram. What we also find is this angle matches to this angle. And then the interior angles all add up to 360 degrees, as they do with all of these shapes. And then finally, I've got a trapezium. Oh, you'll note also that on the kite, there are no parallel lines. If there were, then it would become a rhombus, but there aren't. The trapezium, you have only one set of parallel lines. Otherwise, if the left and the right hand sides were parallel, then it wouldn't be a trapezium and it would in fact be a parallelogram. And all four angles, you could have some matching angles, but a trapezium doesn't have to have matching angles. So they could be all four being different. And then finally, I've got a little question down here. Let's see if we can work this one out. If we want to find out what x is. So there's a few bits of information that we need to determine first. Firstly, interior angles add up to 360 degrees. So 360 degrees is equal to all of these things to put together. So I was going to try and write that as blue. You got the x, and then we have plus this 60 down here, plus 100 over here, plus this angle. Now, they haven't given us that angle directly, but what we can determine is that given the reflex angle here is 260, a full revolution would be 360. So this angle must be 100 degrees. So now we'll do a little bit of maths. Equals x plus 260 degrees. Subtract 260 from both sides. Remember, what you do to one side of the equation, you need to do to the other. So over here we get 100 is equal to x. So yeah, that seems right. Although my diagram isn't really to scale, it would indicate that x is 100 degrees. Beautiful. Alright, that's it from today's lesson. Thank you for listening, and make sure you record some of this information down, because again, like a lot of these topics, a lot of it you just need to know. Alright, thanks for listening. Goodbye.